Unit 3. I'm going to concentrate on the stem and leaf diagram, quartiles, and the box and whisker diagram. Now the stem and leaf diagram, as the name suggests, the diagram has a stem and a leaf. This output is generated from Minitab. As indicated in your course guide, the statistical outputs for this course will be generated from Minitab. You are not required to use Minitab, but we're just indicating to you that Minitab is a software used to give the outputs as opposed to other statistical software or maybe even Excel. Now, here we have the Minitab prompter, MTB. That is just indicating that's the Minitab prompter. And this is a stem and leaf diagram of complaints. So these were numbers, maybe complaints about a particular service. All right. So the number of complaints, let's say, in a period of time. So now we have stem and leaf of complaints. Now, what's important in our stem and leaf diagram is the leaf unit. That's very important to how we interpret the digits. Right? It's very important how we determine the digits. Here we have n equal 100, indicating that we have 100 numbers in our data set, or 100 numbers represented here in this stem and leaf diagram. Now, these digits on the left, those are the leaves. Here in the middle, that's the stem. Now, the stem is your leading digit, while the leaf is your trailing digit. And it's important to look at the leaf unit, as I said before, in order to interpret these digits. Now the leaf unit is 1. So this indicates that this 9 is 9 ones. So if I have 9 ones, if you remember in kindergarten, 100 tens and ones, so we have 9 in the ones column. And in front of that we have 2, 0. That number reads 209. So our value here, this first number represented our stem and leaf, would be 209. That would be followed by 210, followed by 222, 223, 224, 226, etc. So you may notice that the numbers are arranged in order from smallest to largest. So the largest number in our data set is 308. All right. Now, you may be asking all about this column on the extreme right. Now, that is a counts or cumulative frequency in a kind of a way column. Okay, this is generated by Minitab. Other statistical software may not generate this column, but this 1 is indicating that we have one number so far in our data set, which was the 209. Then this 2 is indicating that we have two numbers so far. The 209 and the 210 gives us two numbers so far. This 10, we have 8 numbers in this row. 1, 2, 3, 4, 5, 6, 7, 8. So that gives us 10. Right? So you're adding the frequencies of each row as you go along. However, you may realize that in the very last row we have 4. Right? So there's a point where we stop adding coming downwards and we start adding going upwards. We have 4 numbers in this row. We have 4 numbers in the second to last row. So that gives us 4 and 4 gives us 8. Then we have 8 numbers in the third to last row, which will give us 16. Right? So we're adding from the top. We're also adding from the bottom. And it meets right here where we have 50 and 50. Okay? I'll use the next slide to illustrate where we stop in adding upwards and downwards. Right, this slide isn't a good example to demonstrate that. Okay, so as I said before, your stem and leaf, the leaf unit is important in interpreting the data, the values in the data set. First value here is 209. maximum value is 308. The leaf unit is 1. Let's look on a situation where the leaf unit is not 1. Alright, the question says a new machine is purchased and put into operation. A sample of 50 units is taken from the new machine, and a Minitab was used to generate the data. So we have a Minitab prompter, stem and leaf of new machine. So we have data of new machine. N is equal to 50, indicating to us that we have 50 values in this data set. Now the leaf unit is equal to 0.1. So it indicates to us that this 9 is 0.9. Okay, you may want to say 9 times 0.1 is equal to 0.9. Now remember, the leaf unit, the leaf is your trailing and the stem is your leading. So you're going to have in front 9, 7, and then you're going to have 0.9. So that's 97.9. The second value in our data set, that's a 0 here in our leaf. 0 times 0.1 is 0. So this second value is 98.0. Then we have 98.1, 98.3, 98.4, 98.7, 98.9. And our maximum value would be 102.3. So the leaf unit is very important, as I have said numerous times so far, in interpreting the values in your data set. Now you may notice here we have in that counts column a value that is in brackets, and that says 12. Now when you see this bracket is indicating that the median or the middle number in our data set lies in this row. So the median or the middle number in our data set lies in that row. And Minitab uses this 12 to indicate the number of values in that row. So the 12 isn't a cumulative value, it's a frequency value. Okay, so this column is really referred to as a counts column rather than a cumulative frequency or a frequency column. Okay, so the 12 indicates, as I said before, 12 numbers in this row. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the brackets indicate that the median lies in that row. Okay, the slide before, it so happens that we have 100 numbers. So there are 2 numbers that would lie in the middle. If we have an even set of numbers, you'll have 2 numbers in the middle. And in this case, it so happens that one of those numbers was in this row, while another was in this row, right? So the 2 values are in different rows, and so Minitab wasn't able to indicate the row that the frequency was in and to put the bracket, right? So that's why that one didn't have it. But here, the median, it will be 2 values again because we have an even set of numbers, but both values lie in this row. Okay? Now, there are times when I may ask what I may leave this blank N is equal to question mark, and you're asked to determine what is N. Right? You can do that by counting each value in the leaf. 1, 2, 3, 4, 5. Count each of these values in the leaf. But that is time consuming. Right? And in an exam, you're limited for time. There's another way, however, and that's using this counts column. Alright, you can use the counts column. You look at the value in brackets with a frequency of 12 plus the frequency above it, the cumulative frequency above it, and the cumulative frequency below. So 17 plus 12 plus 21 adds up to 50. Okay, so here's a question for you. What is the value of N? Okay, you should have gotten N is equal to 100, 27, that is where you're going to start, 25, 48. that adds up to 100. All right. Now, if we look on this stem and leaf diagram, it's a stem and leaf diagram of sales, right? So these are some sale figures. The leaf unit is 10. Okay, so this 0 here would indicate 0 times 10, which is 0, right? This 2 would indicate 2 times 10, which is 20, so that's 20. In front of that, in my stem, is a 0. So I have 0, 2, 0, which is 20. I have 20 again, 30, 40, 50, etc. My maximum value, this is a 0 here in my leaf. There's a 2 in front, so that will be 200. Okay, because remember the leaf represents tens, so in front of that you'll have hundreds. Now let's look on constructing a frequency distribution from this stem and leaf diagram. Now in my stem, you notice I have 5 zeros here and followed by 5 ones, and then I have 2. And as I indicated before, in the stem, these values would indicate hundreds since my leaf is ones. And we go back to kindergarten with our 100, tens, and ones. If you remember that column, hundreds, you add your H, your T, and your Z, and your O for the ones. Right? Now, between 0 and 90, if you notice, those numbers were split up into 5 rows. Right? In the first row, now a key thing to note is that the class width of each of these rows is supposed to be the same, right? In other words, the number of numbers allocated in each of these rows should be the same. Note also that if my leaf unit is 10, then the values in my data set can be 0, 20, 30, 40, 50, 60, 70, numbers that are in tens, right? Those are the values that will be displayed here in this stem and leaf diagram because my leaf unit is tens. Now we have established already that the first value here is 0. Then the next one is 20, 30, 40, 50, right? Now in the first row, any number between 0 and 10 or 0 and 10 would be counted in that row. Then in the second row, 20, 30 counted in that row. Third row, 40 to 50, 60 to 70 in the next row, 80 to 90. Notice there's a pattern, right? Then you have 100 to 110, 120 to 130, 140 to 150, 160 to 170, 180 to 190, then 200 to 210. All right? Now notice the width of each of these is 10. Okay? Now for the frequency column, in the first row, there's only one value, 0. So the frequency is 1. In the second row, we have 4 values, frequency is 4. Third row, 2 values, frequency is 2. If you look at the second to last row, there are no numbers between 80, 180 and 190, so the frequency is 0. Okay? Our total frequency is 100, which we're not surprised because n is equal to 100. Alright, so I hope you are able now to interpret this stem and leaf diagram. You should know that the leaf unit is very important. You should also be able to construct a frequency distribution table, also cumulative frequency and relative frequency distribution from that stem and leaf diagram. All right, now here's a question for you. This is a stem and leaf of prices in cents per pound. So these are money, right? N is equal to, that's missing, and we are told that the leaf unit is 0.1. All right, so we know that the first digit here is going to be 16.4, and then we have 16.8, and the maximum would be 20.8. Okay, I think we all understand that, and I think I gave away parts B and C. However, take 2 minutes or less and attempt those 6 questions. Okay, you may need to pause the video. The answers: n is equal to 28, which you obtain by 11 plus 4 plus 13 to give you 28. The lowest value is 16.4. Highest is 20.8. The relative frequency of the first interval is 1 over 28. The frequency of the first interval is 1. And the total frequency of this data set is 28. Now the first 5 intervals, if you notice in the first 2 rows we have 16. So in the first row we would have 16 to 16.4, and then we'll have 16.5 to 16.9. All right, notice that the stem, which is the leading digit, is 16. So in each of those rows the value must begin with 16. So it cannot be 17 in any of those 2 first rows. It has to be from 16.0 to 16.9, and then it is split in 2 evenly. So the first row is 16.4, the second row is 16.9 for even distribution. Then we have 17.0 to 17.4, and then 17.5 to 17.9. The fifth one will be 18.0 to 18.4. And the sixth, if you were asked, it will be 18.5 to 18.9. Then we'll have 19.0 to 19.4, etc. Right? I'm sure you get the idea. Now the last question asks, what is the 4 with the brackets? What did that indicate? And your answer would be the brackets indicate that the median lies in this row, and the 4 indicates the frequency of the median row. All right, we're going to move now to box and whisker diagram. Before we can draw the box and whisker diagram, though, we need to know about quartiles. So I'm going to spend 2 minutes looking at quartiles. Now, quartiles, as the name suggests, as shown, the first thing that comes to your mind is quarters. So what we're doing here is dividing the data into 4 equal parts. And for us to do so, we need 3 dividers or 3 positions, right? I have some numbers there, 6, 47, 49, 15, etc. And our aim is to find the quartiles. Now the numbers have to be arranged in order first. So we're going to rearrange them from smallest to largest. So we have 6, then 7, then 15, then 36, etc. Now the lower quartile, or some books say the first quartile, is denoted by Q subscript 1. And the formula to find the first quartile is n plus 1 over 4 term. N is the number of numbers in our data set, right? So let's see how many numbers do we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 numbers. So to find the first quartile, n is 11. 11 plus 1 is 12. 12 divided by 4 is 3. So we're looking for the third number in our data set. So that's the first, that's the second, that's the third. So our answer is 15, right? So this formula indicates the term that we're looking for in the data set. Now this 15 indicates that 25% of the data is 15 or less, or we can say 75% of the data is 15 or more. The second quartile, which is the same thing as the median or the number in the middle, is found by n plus 1 over 2 term. N, as we said before, is 11. 11 plus 1 is 12. 12 divided by 2 is 6. So we're going to look for the sixth term, which is 1, 2, 3, 4, 5, 6, 41. The third quartile, or the upper quartile, is denoted by Q3. The formula is 3 times n plus 1 over 4 term. Okay, so n is 11, 11 plus 1 is 12. 12 times 3 is 36. And 36 divided by 4 is 9. So we're looking for the ninth term. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth term is 43. Okay? It may be easier sometimes. This is just 11 numbers, but what if we had 100 numbers? That last term would be quite a bit of counting. But we can also count for the upper quartile. We can also count from the maximum value. Okay, it would be the third term. The same term that you look for in the first quartile, which was the third term. So it will be the third term from the maximum up. So it will be 1, 2, 3, 43. All right, so here is a question, and you are asked to find the quartiles. You may want to pause the video, attempt it, and then start to play when you have the answers. All right, your first quartile should be 99.3. Right, in this case, we had an even set of numbers, n is 50. So when you add 1, it's going to be odd. So when you divide by 2, you're not going to get a whole number. You get 12 point something. And that indicates to you that you're looking for the 12th and the 13th term. Okay, and you can use the counts column to assist you. You're looking for the 12th term. Here, you know that in my third row, I have up to 9 numbers. With this 9, so up to here is 9. So I could start counting. This would be 10. 11, 12, 13. So my 12th term is 99.3 and my 13th term is also 99.3. Okay, for the second quartile or the median, you know it's going to be in this row with the 12, right? So far you have 17. So this will be 18, 19, 20. You count for the 25th and the 26th. Okay, similarly for the third quartile, you're going to look for the 38th and the 39th term. Now the box and whisker diagram, as the name suggests, it has a box and a whiskers, right? You can clearly see the box here and the whiskers on the end. Now the box and whisker diagram is often referred to as a 5-number summary. It summarizes 5 values, the lowest value or the minimum value, the lower quartile or the first quartile, the median or the second quartile, the upper quartile or the third quartile, and the maximum value. So those are the 5 values that are represented on the box and whisker diagram, right? So as I indicated before, you'd need to know how to find the quartiles in order to draw this box and whisker diagram. Now in drawing the diagram, it has to be drawn to scale. I have a diagram here showing cholesterol values of adults, and you can see that the minimum value is 154, the first quartile is 180, the median is 197.5, third quartile is 211, and the maximum is 265. Okay, so which of these values, which of these statements are true? All right, that's the question. Which of these statements are true? Okay, more than one of these would be true. And the ones that are true, about 25% of the adults have cholesterol levels of at least 211. Okay, 211, that's true. Okay, at least 211. About 25% of the adults have cholesterol levels of at least, that means 211 or more. So that statement is true. The third quartile, 25% of the data is that value or more, while 75% is that value or less. Okay. B, half of the cholesterol levels are between 180 and 197.5. 180 and 197.5, that's not true. That's 25% of the data. Between the first quartile and the median is 25%. Between the first quartile and the third quartile, that's 50%. That is true. So statement C is true. And D, about 75% of the adults have cholesterol levels less than 180. Less than 180. This is 180. That's our first quartile. About 25% of the adults would have cholesterol levels of less than the 180. 75% would have cholesterol levels of more. All right. Now here is two box and whisker diagrams. We use box and whisker a lot for comparing two sets of data. So this shows the bowling average of the present bowlers of a cricket team, and also the bowling average of past bowlers of the cricket team. All right, and you can easily compare these two, the performances of the bowlers. All right, that brings us to the end of the presentation on Unit 3, stem and leaf diagram, quartiles, and box and whisker diagram.